So we're going to talk about all the periodic trends. So we have the atomic radii, the ionization energy, the electron affinity, and electronegativity. All of those are related to this effective nuclear charge that we learned about before. So remember, there's a whole video on this. The effective nuclear charge is the total nuclear charge minus the shielding. The shielding, if you look at the previous video, is the inner core electrons are pushing out or repelling the outer electrons, just as all those electrons are being pulled into the positive nucleus. So there's the nuclear charge pulling in the electrons, but then that's lessened by the core electrons pushing back out. So I want you to think about that as we go through some of the trend explanations. So Z, nuclear charge, that has to do with the number of protons, and we're going to look at examples where the number of protons are increasing, so that's going to be significant. So coming over here, this top part, so we're going to do all of these trends for what happens when you go across a row. So real quick, I have the periodic table up here. So we're going to do some of them where we go across a row and see if that, whatever we're talking about increases or decreases. And then we're going to do other ones that are down a column. So either down a column, what's the trend? Across a row, what's the trend? And there's different properties to each. So first, let's start with the trend for the effective itself, the effective nuclear charge. So when you go across a row on the periodic table, so when you're going across, the number of protons increases. So remember, the atomic number is increasing as you go from left to right. So if the number of protons is increasing, then your nuclear charge is increasing. So just Z, the nuclear charge. And then the second thing that's happening as you go across the row is the number of inner electrons doesn't change. So this shielding mostly is from inner electrons shielding out the outer electrons. Well, when you're in a particular row or period, all of those have the same electrons that are inner electrons to them. So that means since the number of inner electrons doesn't change, the shielding doesn't change that much. So the shielding doesn't change that much. The nuclear charge is increasing. That means the effective nuclear charge is increasing. So these two are always kind of competing for whether this is going to go up or down, the effective nuclear charge. So then if we go down a column, so that was across a row. If we go down a column, so protons still increase, so you still have an increase in the nuclear charge, but every time you go down the column, you're getting to a different principal quantum number. So you're going from n equals 1, n equals 2, n equals 3, n equals 4. So as you're going down, you're adding on another shell of inner electrons. So here you still have the same inner electrons. Here you're having more and more inner electrons as you move down to higher n values. If you have more inner electrons, the inner electrons are related to the shielding. That increase in shielding is greater than the increase in the nuclear charge. So protons are increasing as you go down. So the nuclear charge is increasing. But what happens even more is the shielding effect. So the shielding change is greater. So that means that Z effective decreases as you go down the column. Same idea when we talk about all these other properties that go along with the periodic trends. So now let's talk about atomic radii. So atomic radii is sort of this average distance between two nuclei bonded together. There's a good picture of it in the book, but for right now, let's just focus on what the trend is. So think about atomic radii is like for the average distance of electrons around the nucleus. As you increase in your N, the shells, you get like electrons that are further and further away from that nucleus. So as n increases, so remember these periods are n, so n equals 1, n equals 2, n equals 3. So as you go down a column, the n's are increasing. The higher the n, and that was kind of the visual here, the higher the n, the farther away you are from the nucleus. And think about atomic radii as kind of telling you how far you are from the nucleus. So this doesn't have as much of, of a relationship to Z effective because you're going into these other shells. This one does. So as we go across a row, so across a row, just like up here when we were going across a row, so you're in the same end. You're in the same principal energy level. So the shielding that you have, since you're in the same n value, it's pretty small. There's some, because electrons can shield each other within the same n, but it's really small. But as you're going across, you're increasing Z, which is a nuclear charge, because you're increasing the protons. So you're increasing Z, and you know that because the nuclear charge Z is the protons that are in the nucleus. So you go across, that's increasing. The shielding really isn't increasing that much. So the nucleus itself is exerting more of a force on those electrons. So positive nucleus, electrons in the same shell. As the nucleus gets more and more positive, because you get more and more protons, it pulls in those negative electrons. So as you're going across, you're in the same n. And if you're in the same n, what's happening is, this is the n. As you go across, you get more positive nucleus, and then that pulls in the electrons closer. So that, in effect, decreases the atomic radii as you go across. So the atomic radii gets smaller across a row. It increases down a column. And then we have the Z effective increasing across a row and decreasing down a column. So next we'll talk about the ionization energy trend.